Solve the equation 4 cos theta plus 1 equals 0 for theta to two decimal places, where theta is greater than 0 degrees but less than 360 degrees. To solve this problem, we want to use our 4 steps below, where our first step is to solve for the trig equation. So in the question, we're given the equation 4 cos theta plus 1 equals 0. And we want to solve for our trig equation of cos theta. So to do this, we need to isolate cos theta by subtracting 1 from both sides and then dividing both sides by 4. And we're left with cos theta equals negative 1 over 4. Now we move on to step 2, where we identify the quadrants that this equation will lie. As we can see, cos theta has a negative value. So we need to use the quadrants where cos is negative. Well, we know in quadrant 3 and in quadrant 4, only sine and tan are positive, meaning cos will be negative in both quadrants. Now our next step is to find the reference angle. Remember, the reference angle is the acute angle between the terminal arm and the x-axis. Now to find our reference angle, we want to solve for theta in our equation of cos theta equals negative 1 over 4. But because we're not using exact values, we need to use our calculator to solve. So to solve for theta, we take the inverse of cos of the positive ratio. And plugging this into our calculator, we get a value of theta of 75.5 degrees. So we know that our reference angle is 75.5 degrees. Now let's draw this on our graph. We know our reference angle in both quadrants is 75.5 degrees. So now that we've found our reference angle, let's use our graph to find our final answers. For our first terminal arm, our standard position angle looks like this, and for our second terminal arm, our standard position angle looks like this. So let's start by finding the angle of our first terminal arm. We'll label this angle as theta 1. So to solve for theta 1, we need to find the difference between 180 degrees on our x-axis and our reference angle of 75.5 degrees. So 180 minus 75.5 leaves us with an angle of 104.5 degrees. Now let's look at our second terminal arm. We'll label this angle as theta 2. Now as you can see, the standard position for theta 2 passes the 180 degrees. So to find theta 2, we take 180 degrees and add that on to our reference angle of 75.5. And adding these two values together, we're left with our answer of 255.5 degrees. And so our final answer for theta 1 is 104.5 degrees, and our final answer for theta 2 is 255.5 degrees.